Hi, welcome everybody to my talk about Akka cluster management and split train resolution. It's a kind of experience talk, so what we experienced while using Akka, and we want to share with you, or I want to share with you. Something about me. Yeah, this is me, I'm Niko Will. This is my dog Elvis. And yeah, we're living in south of Germany, near the Lake of Constance. I'm a software developer since 2005. And since 2007, I'm working as a consultant at InnoQ. And yeah, this is my Twitter handle, if you want to follow me. Okay, let's look at the agenda for today. Just want to have a quick recap why we maybe want to have a cluster. Talking about Akka cluster a bit, setting the ground, a bit the happy path, what's the membership life cycles of joining and leaving a cluster, and then the more advanced things like split brain resolution, how can we do that on our own, what Akka provides for doing this, and so membership life cycle a bit further. And at the end, with all this knowledge, we will implement our own split brain resolver. Okay, so why a cluster? One thing is compute power. You can have very powerful machines, especially in the cloud, but maybe on one point or another, one machine is not enough to handle your load. So maybe you want to spread over several machines to be able to handle your load. The same thing is true for the state. So you can get a lot of memory, but maybe at some point, the state you need to keep in memory does not fit on one machine anymore, so you need to spread your state over several machines. And a very good reason is fault tolerance. So if one machine dies, there are several others which can take over the responsibility of this failing machine. Okay, so this is general why a cluster could be interesting, and today it's about Akka cluster. So sooner or later you have the same point with the Akka application that, yeah, your state does not fit on memory or fault-tolerant reasons. And then you start spreading your actors to different machines. Maybe you start with Akka remoting and do the stuff yourself. But sooner or later, you will come to Akka cluster because it does a lot of the nasty parts for you. Okay, let's look what an Akka cluster means. So Akka cluster is a set of membership nodes, member nodes, which can contain some parts of the application. The membership state is CRDT, which is communicated amongst the nodes via a gossip protocol. And a gossip, you can reach convergence in this gossip protocol if at a specific point in time all nodes have seen the cluster state. So if one node is unreachable in the cluster, not all nodes of the cluster can see the state, so the membership state cannot converge. That means that during a network partition, it's not possible to add new nodes or remove existing nodes from this membership state. We have a failure detector in Akka, or Akka has a failure detector, which is there for detecting if a node is reachable or unreachable. So detecting if it's unreachable and maybe if it becomes reachable again. Akka cluster has a leader, which is, in the case of Akka, not deterministically, which is not a leader election, it's deterministically recognized. And the leader is there for changing joining nodes into an up state or leaving nodes into a removed state. And we have seed nodes, so that a new node which wants to join the cluster has some nodes which he knows of, which he tries to contact and say, okay, I want to join. So let's look at the membership lifecycle. As I said, we have this. We have a new node which wants to join. So it begins in the joining state. It's in this state, And after all nodes have seen that this new node wants to join, the leader can move it to up. So the leader says, okay, you're part of the cluster, you're up. The node can start its work. If sooner or later it wants to, for whatever reason, be removed from the cluster, so leave the cluster, it can do it gracefully, saying, okay, I want to leave. And then all nodes in the cluster have to see this in the CRDT, in this membership state, that this node wants to leave. And just then the leader can say, okay, we put it in the exiting state. And if all nodes of the cluster have seen this node in the exiting state, the leader can put it to remove, and then it's not part of the cluster anymore. So this is the happy path. So if nothing goes wrong, this is how it usually works. Let's see it in a bit more detail what joining means. We have, as I said, we have the seed nodes. We can use the configuration for that, so we can just hard code the IP addresses, host names, whatever, in the seed nodes. We can do it manually, so via JMX, for example, we can add new nodes to the cluster or remove them, and there is also a HTTP API since Akka 2.5. Previously, it was a command line tool. Or we can do it in code. And in code, it's just, we say, okay, cluster from the system, join seed nodes, and given a list of seed nodes. So we can, for example, go to DNS console or whatever, do a service discovery to get some of the nodes of the cluster to join them, and we give the list here and try to join them. Then it's good after that we wait for the cluster. Means the leader will set a node from joining to up. So when we start, we could, for example, process messages immediately from a message broker or whatever. But when we're in the joining state, we're not part of the cluster, so it's not a good thing to do. So we should really wait until the leader says, okay, now you're up, you're part of the cluster. There are a few configuration options we could use. For example, that we say, okay, a Akka cluster must have at least 5 nodes. So we can set this configuration option to 5, and then the leader will set joining nodes to up no sooner than if there are at least 5 nodes in the cluster. And we can do this role specific. So we can add a specific role to a node, like front end or back end or something like that. Yeah. And as I said, we should start processing jobs or, for example, messages first when we're moved to up. And there is a callback you can register for. So you can say to the cluster, register a member up, and then do your initialization of your other actors, like here the factorial front end actor, in that callback. Okay, then come to the leaving. When stopping the actor system, it makes sense to leave the cluster gracefully. So we can do this manually again with JMX or the HTTP API. As I said, cluster management tool if we're previous to 2.5. We can do this in code. Almost similar. We can just say to get the cluster and then leave the cluster with our own address. And it's a good thing to add a shutdown hook for the JVM to say, okay, if maybe we have then time to, if we're forcefully from the outside to stop our application, we can leave the cluster in the shutdown hook. Just a short note, if we have a split brain resolver in place, then others will notice that we were shut down, and we wouldn't need to do that, but it's still, if we're a good citizen, we try to to do this gracefully. We have the same as for joining, we have for leaving. So after a member is removed for whatever reason, the actual system itself and the JVM process is not stopped. So it could be that, for example, the leader, for whatever reason, decides our node is removed from the cluster, and then our application would still run. So we can register another callback saying if what should happen when we're removed, and then it's a good thing to terminate the cluster or terminate the system. And then system exit the JVM. As a short note, in Akka 2. Or since Akka 2.5, there is some kind of coordinated shutdown. So if you, it's there for, it shut down some actors in a specific order. And if you use Akka cluster is part of that coordinated shutdown. So this thing is handled automatically for you. So for example, if you just kill your application from the outside, it will automatically do this graceful shutdown, for example. So you don't have to take care of this. But if you're, for example, consuming messages from a message broker or something like that, then it could be a good thing in that part to maybe close the connection. Okay, so we have joining, we have leaving, so we're ready. We have everything we need. We can. Oh, I love this. I've said when I will do my first presentation, I will need to include that. So, yeah, but we're done, right? So we have everything we need. Our cluster is up. We can join. We can leave. But then things go south. We see log messages like this. I highlighted them a bit. Leader can currently not perform its duties. Oh my God, what could that mean? And then we see, if we go a bit further, we see, okay, there is an unreachable node. Oh my God. As I said before, this is not good. Unreachable nodes, we cannot reach the gossip conversions, the membership conversions, and no new nodes can join. That's why the leader cannot perform its duties. So this is not something we want. Okay, for this we have to look at network partitions first. I hope you all know the CAP theorem, that we have consistency, availability, and partition tolerance, and we only can choose two. In a distributed system, partition tolerance is more or less mandatory. And in the end, it means that somehow there can be network partitions, but a network partition a network partition is not clearly distinguishable from a machine crash, for example. So if it could be, we have a network split, so this side cannot communicate with that side, but it also could just be that these two nodes have crashed. And the same is, we don't know if it is a temporary or permanent failure. So the network could come up again or be down forever. And another thing is, it could be just unresponsiveness. So we're on JVM, it could be garbage collection or whatever. So maybe these two nodes are just in a garbage collection pause and are not responsive anymore. So do not respond to the heartbeats of the cluster gossip and considered as unreachable. So yeah, this is the main problem we have to handle somehow. And a thing how we could handle this is split brain resolution. If you're lucky and have a lightband subscription anyway, or you maybe want to establish one just for the split brain resolver, then there are a few available. And if you have a lightband subscription and they fit your needs, then look at them and maybe they're already right for you. Then you have to do nothing. There are a few like static quorum, which is good if you have a fixed size of cluster. For example, 10 nodes, then you say the static quorum is, for example, 6. So if one node crashes, for example, but the other 9 can still see each other, then they know, okay, we're above the static room size of 6, so we're in the majority, we just remove that other node from the cluster. But all of these also have some downsides, like it's trade-offs. So look at the documentation if you can live with the downsides, for example. So if you add more nodes, for example, if you add another 10 nodes, then the static quorum size of 6 is maybe not good for 20 nodes. In such a case, maybe keep majority is the right resolver for you. So that always, if you have a split and 2 nodes are separated from the other 8, then these nodes are considered as down and the other 8 nodes will take over their responsibility. Maybe the keep oldest is more interesting for you. Usually on the oldest member there is the leader, and for whatever reason it could be that this is more interesting for you to keep the oldest, but then it can happen, for example, that you have 100 nodes and the leader is the only node which is somehow separated from the other 99, and then all the other 99 will shut down and the leader is the only node which has to handle the rest of the load. So another downside, but it could be that this is something which is okay for you. And a keep referee is that you can specify a specific node saying this node has special resources for whatever reasons. And no matter what happens, I want to keep that node and all nodes which still can see that referee node. Then you can choose this strategy. So these are from Lightband. If you have a Lightband subscription, look at them. Maybe they fit your needs, and then you're done already. But Akka also gives the possibility to bring your own split brain resolver. And Akka provides a lot of stuff to implement them, and it's not a really hard thing to do because Akka provides a lot of things. And before we look at our own implementation, we look what Akka actually brings us. One thing is we can register for cluster events. So we can just say in any actor, we can say, okay, to the cluster we want to subscribe. For events, we can say, okay, we also want the initial state as event, and we want to register for all or subscribe for all domain events. And as a good citizen, in the post stop, we also unsubscribe from these events. And then this could be the release function of this actor, where we get all these membership state updates. For example, the current cluster state, which will deliver this CRDT membership state. We will see soon. We get notified if a new member comes up in the cluster and have the member as a parameter. Member weekly up, I will come to that later, is another state which is sometimes handy. We get notified if a member is detected as unreachable in the cluster. If we are notified if a member is removed from the cluster, and yeah, the rest maybe we can ignore. The cluster state itself, this is this CRDT I was talking about earlier, which is which merges over the several nodes. And this cluster state has a list or a set of all members of the cluster. And it has a set of all unreachable members. If a member is unreachable, if it is in this set, it is automatically part of the member set. And here we have the seen by. If all members which are in the member set are also in the seen by set, we know we have a converged state. So this means there cannot be any unreachable in this case. And we can get the leader out of the state, and as I said, front-end nodes, back-end nodes have their own leaders. We can access the leader map for that. Okay. With this, we could, for example, implement a small health indicator already, which could be handy to expose the health state of the cluster so that we can monitor it from the outside, for example, and alert something if maybe the cluster is not healthy over a longer time. And when is our cluster not healthy? If there is at least one unreachable member. How could we detect this? If we look at the cluster state, look into the unreachable, if this set is empty, we know we're healthy. If it's not empty, then we're not healthy. Okay, another thing, looking again at the membership lifecycle, there is this unreachable state, as I said already. I talked about earlier, we have this failure detector, so from every state a node can be in, the failure detector can detect it as unreachable if it doesn't receive the heartbeats anymore. And then it's not really a state unreachable, it's a flag. So this node is flagged as unreachable then. And it can become reachable again, detected by the failure detector, or we can move it to down. We will see that later. Okay. Yeah, as I said, it's detected by the failure detector, which can be fine-tuned. Look into the documentation, which is really great. There are a lot of options you can fine-tune. If there are unreachable members, like we have seen before, leader cannot perform its duties. That's what you usually get as a log message. And as I said, no new members can join in such a state, and no exiting members which want to leave gracefully can be removed from the state, because not all of the other cluster members will see it, because some of them are unreachable. But it does not influence the running members. So even that node which is unreachable could still be running. You don't know. It could be separated, or it could have crashed. But it does not influence your application which is running on that node. And unreachable members are still part of the cluster. As I said earlier, in this CRDT, they're still part of the member set. So their responsibility will not fail over in this moment. So if they're unreachable, and for example, you have Akka persistence with shards over the cluster, for example, then the shards these nodes have are still on this node. So no other node will take over the responsibility for that shards. So in other words, keeping unreachable members for a longer time in the cluster is not really desirable. In order to really move forward and continue having a fully working application, we must change that somehow. And so they must become somehow reachable again, maybe through a restart, or we have to remove them from the cluster. And removing, we have seen earlier, is putting them to down, so downing them. This part, if it is in this state or flagged as unreachable, we can mark it as down, and then it's also removed from the cluster. So if you have one unreachable member, you down it, it will be removed from the cluster, you have a cluster which is healthy again. Let's see how this downing works. As I said, it will remove the member from the cluster, and and the rest of the cluster will take over the responsibilities of this node. There is the possibility of auto-downing, which you can just enable. This means that if I cannot see the other node, I will down this node, so I will remove it. But the other node, if it's still working, will do the same with me. So you have two clusters, which is not what you want. So be careful with that. For development, it could be okay, but never use it in production. But every member can mark itself and other members as down. In code, this looks like this. It's quite easy. You go to the cluster and you say down and give the address. We will see in a minute what we can do with that. Another thing we have seen is weekly up members. Weekly up members are also part of the membership lifecycle. If the cluster is unhealthy, if there are unreachable members, as I said, a joining node cannot be moved to the up state. But if we enable that feature previous to Akka 2.5, in Akka 2.5 it's enabled by default. If you use Akka 2.4 something, then you can enable it. That a leader is able to move a joining node into a weekly update. So it's part of the cluster, but does not really have responsibilities. So it will not take over any Akka persistent shards, for example. But it's part of the cluster state. This is something we will see in a minute, that this is a fact we could also use for our own split brain resolver. Okay, then it's time for our own split brain resolver. How could we do this? We could write a custom downing provider. So I've talked about this auto downing. It's nothing less than an implementation of the downing provider. And then you can, in the configuration, set it to your class. And there are a few options. So auto down unreachable after. You can set a few things to tune the implementation a bit. But as I told you earlier, it's just registering for cluster events, and then you have these methods to down other members. So it has not to be a downing provider. You can do this in any actor. And then you can implement custom strategies, for example, using the cluster state. So reachable versus unreachable members. For example, if you think about majority is nothing less than looking into how many reachable members do I see and how many unreachable members do I see. If it's more unreachable than reachable, then I'm in the minority. And I can shut down myself, for example. And the other nodes, which are in the majority, for example, can down all the unreachable nodes, and the cluster is healthy again. So this could be something you could use for your own split brain resolver. And as I said earlier, the member state weekly up is also interesting, because maybe this node was previously part of the cluster and comes back up again with another address. Then it's not detected by the failure detector that this node is a node which was part of the cluster, and then you have to handle that on your own. We will see that in a minute. Now I want to come and explain what we did, so how we implemented our own custom split brain resolver. We had 2 data centers. And 2 data centers is always a bad thing, because you cannot really do majority. If one data center is down, how do you detect which one? Or if one is not really down, but maybe separated from the internet. You cannot detect in the data center itself if it is the one working. So we had a kind of special setup. So the data centers were quite smart, I would say. If one data center is down, then the data center logic will start to move the nodes. So the state of each node, the memory and everything, is somehow magically persisted somewhere. And if this data center is gone, this data center will somehow recognize this and start nodes which were running previously here on the other side. So each node which were running on the other side is now moved to this data center, which is still working. But as I said, this will be not detected as the same member as before, because the IP address may have changed, or the port, or whatever. So Akka cluster, the failure detector, will not detect these nodes as it were the previous node. So what we did, we also did some kind of majority check. We had equal clusters on both sides, for example, running 10 nodes. And then when the nodes are shifted to the other side, there will be more nodes than on the failing side. And with this, we can do some kind of majority check. We can say, okay, if there is a majority check scheduled, we send ourselves a message. If we get this message and there are no unreachable members, we don't have to do anything. So we're in a healthy state. But if there are unreachable members, so the set is not empty, we go and take all the unreachable. We take all members without the unreachable. So we know these are the reachable members. And then we can just say, okay, if the reachable size is bigger than the unreachable size, we know we're in the majority and we down all from the unreachable side. If the reachable size from our point of view is lower than the unreachable size, we know we're in the minority and more or less we down ourselves. So we down the still reachable side. If it's equal in this case, so if there is no majority and no minority, we do nothing, because then the split just happened and the data center logic did not start to move the node. Then we have this normal membership events like member up. So if a new member has joined and the leader moved it to up, we just keep its address. We somehow, magically in this case, get the host name and the member and store it in the known address. And yeah, we check, we schedule a majority check. If a new weekly member comes up, so that means we have unreachable members at the moment. If a new member comes up, we go to the known addresses and magically resolve the host name of this member. And if it is maybe an already known member, which we're running on the other side, we would get the same host name for it. And then we can filter, is it in the unreachable? And if it's in the unreachable, we can say, okay, we want to down this previously incarnation of this node, which we're running on this other side of the data center, so in the not more available side. And then we can schedule a majority check. If this happens only once, then we removed, we downed this single node, which is then removed from the cluster, and we're in the majority on this side. And this majority check I showed you earlier will then decide, okay, we're in the healthy part, the other are in the unhealthy part, which are not longer available. So we will down them, and we're in the majority, and we're the side which are still up. Yeah, and if a member is removed, we just remove it from the known addresses. And if there is a new unreachable member, we just schedule that check. Was it clear what I want to tell you? So if one node is moved from the data center logic, from the not more working side to the other side, it will come up as weekly up member. We will detect this. We will see this node was already known. It was already part of the cluster according to its host name. And we will see, okay, we have this node as an unreachable part of our cluster, so we will remove it. And then our side of the cluster is in the majority. And then when we're in the majority, we will just down all unreachable, and then our part of the cluster is the working side. And we're convergent again, and we can take over all the responsibilities of the other nodes and have a fully working cluster. And the same happens on the unreachable side. Remember, the nodes on the unreachable side can still work. They can still reach each other, but not the other side in the other data center. But if the data center logic starts to move these nodes from one side to the other, they are shut down on the other side. And then they're sooner or later in the minority, and then they will shut down themselves. And then we're up again, we're working, the cluster is healthy, and if something happens, the cluster handles itself. And yeah, this is it. Thank you. Any questions?
Can the magic data center logic be named? So what are we talking about? Some virtualization?
I don't know what it was running underneath, but I think it was quite expensive.
Okay.
It was a bigger company. I don't want to tell you the name, but yeah.
So any questions?
But at least what I wanted to show you that Akka brings a lot of stuff you just can use, and it's really easy. And the guys from Akka really did a lot of thinking, and they really know what they're doing, and make it easy for you to handle really complicated stuff in a I think very easy way. And the documentation is quite good. So from reading the documentation, maybe twice or more, you can get this information out of it, and yeah, implement such things on your own. All fell asleep.
No, I think they're lost in thought. Okay, we have a question.
So what you did is publish somewhere as open source, or is just a project you made for this talk?
Sadly, not open source, because the company I was working for has not a real open source culture. But I mean, you at least you have my slides, you have the idea how to implement it, and you see the code. It's not that hard. The real production code, which was running over 1 year and has some failover testing gone through, so it really works, and it's not much more than what I've shown you on the slides.
Okay, so basically you were working for a project and you implemented for the project. You didn't make.
Exactly.
Okay.
Exactly.
Thank you.
In terms of testing, can you give us your thoughts? Because we used to use Akka cluster, the library, pre 2.5, but it was a little bit of pain to test. And then I read maybe one of the recent Akka books, and they present examples where they do the setup of the tests in different JVMs, but it just looked very, very complicated to me. Maybe it's improved a little bit, and it's definitely an improvement over what we had before, but I want to hear your thoughts on that, and maybe if some of the Akka people can.
I think distributed system testing is always hard. As I said, so the best test for us was really so before the whole thing went live, they really shut down one data center, and then we saw the whole magic live. This was maybe the best test you can have. We had not really the opportunity to test this locally in terms of a real cluster. What we have it was running in Docker, for example, and then you can shut down arbitrary Docker nodes and see if the other can recover from not reaching that node anymore. But yeah, like unit testing or something like that, I have no experience with that. Maybe the guys from the Akka team.